Good morning. I would like to present the publication, Modeling and Simulation of Composite Materials Used for Permanent Dental Fillings. Plan of presentation. What is tooth decay? Treatment of caries. Methods for prevention of tooth decay. Why is filling roughness so important? Surface roughness testing. Characteristics of the materials tested. Preparation of samples for testing. Results of roughness testing of manufactured samples. Hardness test. Microscopic images of samples after hardness test. Conclusions of test results. Tooth decay is often caused by a diet high in sugar and neglecting to clean your teeth and gums. Tooth decay may not show any symptoms at first. However, if it gets worse, it can lead to problems such as a cavity forming in the tooth. Sometimes the tooth or gum can become infected, leading to a painful buildup of pus, tooth abscess. Early treatment can prevent the condition from getting worse. The number 1 picture shows the equal types of tooth decay. It is important to remember that tooth decay is responsible for more than 500 comorbidities throughout the body. It can cause obesity, cancer, or premature births. Photo number 3 shows the factors that promote and counteract the formation of caries. There are factors that increase the risk of tooth decay developing as well as factors that protect the teeth to try and prevent tooth decay from developing. When the harmful factors outweigh the protective factors, that is when tooth decay begins to form. Factors that increase the risk of tooth decay: poor oral hygiene, hidden sugars in foods and drinks, frequent snacking, a diet filled with sugary foods, decay-causing mouth bacteria, reduced saliva. Factors that protect and decrease tooth decay risk: regular brushing, cleaning between the teeth, e.g., flossing, saliva, diet, fluoride. Fortunately, caries can be treated, but the main problem with tooth fillings is the balance between the practical function of the restoration, mechanical resistance, and aesthetic qualities, which are particularly important in the case of anterior teeth. In the case of posterior teeth, it is important to maintain the high mechanical properties of the restoration. Composite restorations combine aesthetics and high mechanical properties. The treated tooth is filled with composite material. When finishing the filling, it is very important to polish it properly, as a rough surface encourages the accumulation of plaque, which leads to the formation of secondary caries. Since the roughness of the cavity filling significantly affects the accumulation of battery plaque, different types of common tools in the dental office for cavity preparation were tested. The sample materials were fabricated from 2 common materials used for direct tooth fillings. The first is Herculite XRV Dentin, Figure 6, and the other one is Filtech Ultimate, Figure 7. Herculite is a classic microhybrid light curing composite material used to fill all classes of defects in the lateral and anterior teeth. It is recommended for black class I, II, III, IV, V cavities, erosion, and direct veneers. It is characterized by a high content of filler particles, 79%, of weight volume with a small particle size, 0.6 micron. The small filler particle size improves the polishability of the restoration. The manufacturer provides a large palette of composite colors, which increases the aesthetics of the final filling. It should also be mentioned that this material was the first submicron composite used for direct tooth tissue fillings. In vivo studies show up to 20 years of exemplary behavior of the material in the oral cavity. It is characterized by very good durability, mechanical resistance, and very good aesthetic properties. These features have made it a certain standard in many material studies as a model for property comparisons with other composites used for fillings. Filtech Ultimate is a universal light curing composite material used for fillings of anterior teeth, where high aesthetics are required, but also for fillings of posterior teeth due to its high mechanical properties. It is also often used to restore teeth for prosthetic fillings and indirect fillings such as veneers. The material has low abrasion, is easily polished, has good gloss retention parameters, and has enamel translucency comparable to that of natural teeth. The filler concentration is 59.5% by weight and the particles are nanoclusters of 0.6-1.4 micron, 520 nm. The mold used to create the specimens was made of Z+ condensation silicone elastomer, which is used as the first layer of a two-layer impression in dental prosthodontics. Z+ is a material with increased hardness and resistance to deformation, and increased initial elasticity for increased fluidity and dimensional stability. The material was kneaded in the hands for about 30 seconds until a uniform color was obtained. The mass was transferred into a mold in which the shape of the samples was imprinted with metal screws, figure 8. The composite materials from syringes were applied to the cavities created by the screw heads, and then the composite materials were polymerized using a lead lamp, figure 9. 15 specimens for each composite material were made in this way. After polymerizing the samples, they were subjected to abrasive treatment by grinding manually on sand. The samples prepared in this way were divided into 5 groups, in which 3 samples of each group were subjected to a different surface polishing process. Purple silicone rubber polishers and other, gray, yellow, orange, brown. Also the Soflex type processing discs were used for the surface preparation. Roughness measurement in the contact method is performed on the head, which moves at a constant speed, usually in a straight line, on the surface of the tested material, collecting information. The imaging blade, while in contact with the surface, registers changes in position relative to the other elements of the measuring head. Testing for surface roughness is described by PN on ISO 4287, 1999, specifications for product geometry, geometric structure of the surface, profile method, terms, definitions, and parameters of the geometric structure of the surface. In the study, the measurement was carried out using the contact method, where the measurement takes place with the use of a profilogram. The result of the conducted test for Herculite XRV dentin material is shown in figure 10. In the graph, different methods of polishing the surface of the material are marked with colors. The average raw value for Herculite XRV dentin after polishing with a brown Soflex disc is significantly different from the results obtained with other polishing methods, with a raw value of 0.40, which is 20 times better than after using a gray rubber or an orange Soflex disc. The result of the surface roughness test on the samples made of Filtek Ultimate is shown in figure 11. The best surface finish for Filtek Ultimate was achieved with an orange Soflex disc, raw equals 0.2, and the worst with a yellow Soflex disc, raw equals 0.04. The surfaces after polishing with the gray and purple eraser show similar roughness measurement results, raw equals 0.07. Samples made of composite materials were subjected to microhardness testing under conditions specified by PNEN ISO 6507-1. The composite materials were measured using the Vickers method, HV, with a load of less than 1 kg, 9.81 N. For each polishing method, 5 measurements were made using a Future Tech FM-700 hardness test or under a 500 gram load, HV 0.5, and an indentor penetration time of 5 seconds. The results of the hardness test along with the mean values and standard deviation are shown in tables 1 and 2. The arithmetic mean hardness of Herculite XRV dentin material was HV 0.5 equals 96.92 and for Filtek Ultimate material HV 0.5 equals 100.68. Images of the structure of the materials after hardness testing were taken using a light microscope at 40 times magnification. The average raw value for Herculite XRV dentin after polishing with a brown Soflex disc is significantly different from the results obtained with other polishing methods, with a raw value of 0.40, which is 20 times better than after using a gray rubber or an orange Soflex disc. The best surface finish for Filtek Ultimate was achieved with an orange Soflex disc, raw equals 0.2, and the worst with a yellow Soflex disc, raw equals 0.04. The surfaces after polishing with the gray and purple eraser show similar roughness measurement results, raw equals 0.07.